Hello class, in this tutorial, we'll go through the workflow of creating the IKNFK character controller and get our character ready for animation. The model has 4 meshes. The dress is not rigged and will be animated using the cloth tool, so we can disable it for now. The body mesh is fully rigged with joints. Here are the details of the skeleton. Here are the thigh joint and knee joint. Each foot has 3 joints. They are on the ankle, the ball and the toe. Each finger has 4 joints. The head joint controls the head top joint and the 2 eyeball joints. Go to Create, NURBS Primitives, Circle. Scale it up a little bit. We will use this circle as the controller. Go to Modify, Freeze Transformations, to zero out the changes we made to the circle. Delete the history. In the outliner, hit the Command key and the G key to create a new folder. If you are using the Windows system, hit the Control key and the G key instead. Parent the circle to the folder. Duplicate that folder, and we will make the controller for the head joint. With the folder remain selected, hold down the Shift key to add the head joint. Hit the P key to parent the folder to the head joint. In the outliner, you can hit the F key to locate the folder's new location. Now the folder became the child object of the head joint. And its position value is the folder's position relative to the head joint's position. That means if you zero out the folder's position value, the folder will jump to where the head joint is. I selected the circle and scaled it down a little bit. Don't forget to freeze its transformations and delete its history after you applied the change. Now, select the folder and hit the Shift key and the P key to unparent it. Rename the folder to Head and rename the circle to Head Controller. Since the folder is not parenting to the head joint anymore, its position value is its position relative to the center of the world. We put all values on the folder and has clean value on the circle. Now, duplicate the head folder by hit the Command key and the D key. In the Windows system, hit the Control key and the D key instead. Rename the folder to Neck and rename the circle to Neck Controller. Select the Neck folder, hold the Shift key, and select the neck joint. Hit P key to parent the neck folder to the joint. Zero out the position value on the neck folder. The folder will shift to where the neck joint is, and we will use the circle as the neck controller. Hit the Shift key and the P key to unparent the neck folder. Duplicate the neck folder, and we will use it as the chest controller. Parent the new folder to the chest joint, rename it, and repeat the procedure to shift its position. We will create 3 controllers for the spine joints and 1 controller for the hip joint. I renamed this folder to Spine 1 and renamed the circle to Spine 1 controller. Duplicated the folder and make a controller for the next spine joint. Parent the folder to the second spine joint. Rename the folder to Spine 2 and rename the circle to Spine 2 controller. Zero out its position value so it can shift to where the second spine joint is located. Unparent the folder. Duplicated the folder and make a controller for the third spine joint. Parent the folder to the third spine joint. Zero out its position values. Then, hit Shift, P key to unparent the folder. Make sure the name convention is correct. Duplicated the folder and we'll make the hip controller. Parent the folder to the hip joint and zero out the position values. Unparent the folder. Rename the folder to hip and rename the circle to hip controller. Then, duplicate a folder to make the shoulder controller. Parent the folder to the shoulder joint. Rename the folder to shoulder left and zero out the folder's position and rotation values. Unparent the folder. Rename the circle to shoulder left controller. I felt the shoulder controller is a little big, so I selected the circle and scaled it down a little bit. After you applied the changes to the circle, remember to freeze the transformations and delete the history so we have a clean value on the circle. Keep in mind that we put the circle in the folder and we never moved the circle, so the circle has a clean value. We moved the folder and kept the values on the folder, and that's totally okay. We will use the circle as the controller and the folder is just a container. Now we made the controller for the right shoulder. Rename the folder to shoulder right and rename the circle to shoulder right controller. Parent the folder to the right shoulder joint and zero out the folder's position and rotation values. Unparent the folder. Make sure the shoulder controllers on both sides have the same scale. You can type in the scale value you used for the other shoulder controller. I used 0.8. Freeze its transformations and delete its history after you applied the changes. Now, duplicate the initial folder and make the hand controllers. Rename the folder to hand left and rename the circle to hand left controller. Parent the folder to the left wrist joint and zero out the folder's position and rotation values. Unparent the folder. Select the circle and scale down the circle to match the size of the hand. I type 0.6 as the scale value and I will use the same value for the other hand controller. Select the circle and freeze transformations and delete history when you made the changes. Your circle should have a clean value and the folder still kept value for the position changes. Duplicate the folder. Rename the folder to hand right and rename the circle to hand right controller. Parent the folder to the right wrist joint. Zero out its position and rotation values. Unparent the folder. Now we finish the controllers for the torso and the arm. For the next step, we will connect the controller and the joint with Constrain. Since the head joint and the spine joint can only rotate and they are not supposed to move, so we will only use those joints' rotation channels for animation. Select the head controller. Hold the Shift key and add the head joint. Go to Constrain, Orient Constrain. Open the tool setting. Make sure to check on Maintain Offset. Then, Apply. Now, by rotating the head controller, the head joint should follow. Select the neck joint, then add the neck joint. Hit the G key to repeat the last action you applied, which is the Orient Constrain. Select the left shoulder controller and add the left shoulder joint. hit the G key to repeat the Orient constrain. Select the right shoulder controller and add the right shoulder joint, hit the G key to repeat the Orient constrain. We will not touch the hand controller for now and will set different functions later. Let's move on to the spine controllers. If the controllers are a little small and overlapped with the mesh, you can scale them up accordingly. Here, I scaled up the first and the second spine joint controller and the hip joint controller. Freeze the controller's transformations and delete history. Select the controller of the first spine joint, then add the first spine joint. Apply Orient Constrain. Select the second spine controller and the second spine joint, hit the G key to repeat the Orient Constrain. Select the hip controller and the hip joint, hit the G key to repeat the Orient Constrain. Double-check each controller and make sure they are fully functioning. Keep in mind that, before you set the Orient Constrain, if any of the controllers had values and you forgot to freeze transformations, the joint would be twisted. Now, all controllers are functioning, however, each joint work independently, and the nearby joints do not follow. We will parenting the controllers to fix that issue. Now, we will parent the head controller to the neck controller. However, don't parent the controller directly to another controller. Instead, we will parent the head controller folder to the neck controller. You can hit the P key for parenting. Keep in mind that for all other controllers, we will parent the child controllers folder to the parent controller. Now, select the neck folder, then, select the first spine controller, hit the P key for parenting. Follow the same procedure to parent the first spine folder to the second spine controller and to parent the second spine folder to the third spine controller. Parent the third spine folder to the hip controller. Here's the hierarchy of the controllers. Now, if you rotate a parent controller, the child controller should follow. The shoulder should follow the chest rotations. Select the left shoulder folder and parent it to the first spine controller. Select the right shoulder folder and parent it to the first spine controller as well. Now, the first spine controller should have 3 children objects: the neck folder, the 2 shoulder folders. For the leg, we will create IK controllers. See the differences between the 2 legs skeletons. The left leg bends at the knee joint, and that's the recommended way to set up your leg joints. The right leg skeleton is in a straight line, and sometimes the IK control will be confused and don't know which direction to bend. Let's work on the left leg controllers first. Go to Skeleton, create IK handle. Set the current solver to rotate plane solver. This allows the knee to bend and also allows it to aim in different directions. Click on the thigh joint, then click on the ankle joint. Now we've created an IK handle for the left leg. If you move the IK handle to a different location, the whole leg skeleton will move. For the right leg, if you created the skeleton in a straight line anyway, you will have to tell the program which direction would you like the knee to bend. Select the knee joint, rotate it to the direction that you would like it to bend. Then, select the thigh joint and go to Skeleton, set preferred angle. Choose the hierarchy to set angle. Now, the IK knows the joint direction, and you can zero out the joint to the initial position. Go to Skeleton, create IK handle. Click on the thigh joint, then click on the ankle joint. Double check to see if the right leg works properly. Rename the IK handles on both legs. Now, we will create controllers for the knee. Duplicate the initial folder we created earlier. It's easier to hide the polygon mesh before we move forward. Hold the V key and snap the folder to the left knee joint. Rotate the folder in 90 degrees. And move it to the front of the left knee joint. If the knee controller is too big, you can select the controller and scale it down. Please be aware that I'm scaling down the circle controller, not the folder. I put 0.2 on the scale. Once you applied changes on the controller, remember to freeze transformations and delete history. Now the controller should have a clean value, and the folder kept the position and rotate value. Duplicate the folder, hold the V key, and snap the folder to the right knee joint. Move the folder to the front of the right knee joint. The distance doesn't have to be precise, since the leg joints on my model are not symmetry. If you want the distance to be precise, you may copy the Z value on the left knee folder and paste it on the right knee folder. Now, rename the knee folders and the knee controllers. Select the left knee controller and select the left leg IK handle. Go to Constrain and apply the pole vector. Now, the knee joint should aim to the knee controllers. By turning on the polygon mesh, you can see how the controller works. Combining the IK handle and the pole vector, you should be able to create any pose with the legs. Select the right knee controller and the right leg IK handle. Go to Constrain and apply the pole vector as well. Now we have finished the leg controller. However, it doesn't allow us to control the foot movement. Now, we will create IK handle for the foot. On the foot, we want both the ankle joint and the ball joint to rotate, so we would need to create two IK handles on the foot. Go to Skeleton, create IK handle. In the tool setting, choose the single chain solver as the IK solver, since the foot joints only rotate in one direction. With single chain solver, you will not be able to create the pole vector as we've done on the knee joint. Click on the ankle joint, then click on the ball joint. Now we create an IK handle for the foot. Rename the IK handle to IK ball left. Go to Skeleton, create IK handle again. Click on the ball joint, then click on the toe joint. This will create an IK handle for the toe. Rename the IK handle to IK toe left. Follow the same procedure to create IK handle for the right ball and right toe. Rename each IK handle. Now, we created 4 IK handles for the feet, and in the next step, we will create a few joints called reversed foot rig. It would be easier to hide the polygon mesh so we can focus on the joints. Go to the side view. Draw the first joint below the ankle. Then draw the second joint around the toe, the third joint around the ball, and the fourth joint around the ankle. Click on the Enter key to finish drawing, and we will call this joint the reversed foot joints. Unlike the original leg and foot joints, this new joint hierarchy connected in the opposite way. Select the reversed foot joints, hit the Command key and the D key to duplicate it, and we will use it for the left foot. Move the reversed left foot joints to the left foot. You can write down the translate X value and use the value to move the reversed right foot joints. Select the reverse toe joint. Hold the V key and snap it to the toe joint. Select the reversed ball joint, hold the V key, and snap it to the ball joint. Snap the reversed ankle joint to the ankle joint. Rename all reverse joints accordingly. Now, we would like to use the reverse joints to drive the IK handles we created earlier. Select the left toe IK handle and parent it to the reversed left toe joint. Select the left ball IK handle and parent it to the reversed left ball joint. Select the left leg IK handle and parent it to the reversed left ankle joint. Now, if you rotate the reverse toe joint, all three IK handles should follow. If you rotate the reverse ball joint, the ball IK and leg IK should follow. By using the reverse foot rigs, we created an inverse IK control for the leg and foot, which gives you more control over the character animation. After applied the reversed foot rig, both the ankle joint and the reverse ankle joint aren't able to move the foot anymore. Instead, the foot joint will do the job. Now, you can put the same translate X value on the reversed right foot joint and move it to the right foot. Following the same procedure that we did on the left foot, we will snap the reverse toe joint to the toe joint and rename it. Snap the reversed ball joint to the ball joint and snap the reversed ankle joint to the ankle joint. Parent the right toe IK to the reversed toe joint and parent the right ball IK to the reversed ball joint. Parent the right leg IK to the reversed ankle joint. Now, we finish the reverse foot rig for both legs, and we will create controllers for the legs in the next step. Now, let's set up foot controllers. Duplicate the initial folder we created earlier. Hide the polygon mesh so we can focus on the skeleton. Rename the folder to ball left and rename the controller to ball left controller. Snap the folder to the ball joint and rotate it in 90 degrees. Scale down the controller and freeze transformation and delete history. Duplicate the folder and snap it to the toe joint. Rename the folder to toe left and rename the folder to toe left controller. Show the mesh to compare the size of the controllers. Scale down the toe controller, then freeze transformation and delete history. Duplicate the left ball folder and snap it to the right ball joint. Rename the folder and the controller. Duplicate the left toe folder and snap it to the right toe joint. Rename the folder and the controller. Double-check all controllers and make sure they have clean values. Select the left ball controller, then add the reverse left ball joint. Go to Constrain, Orient Constrain. Make sure to check on Maintain Offset and Constrain Axis set to all. Now, the controller should drive the joint's orientation channels. Select the left toe controller, then add the reverse left toe joint. Go to Constrain, Orient Constrain. Select the right ball controller, then add the reverse right ball joint. And apply Orient Constrain. Select the right toe controller, then add the reverse right toe joint. And apply Orient Constrain. Duplicate the initial folder and snap it to the reverse left foot joint. Rename the folder to ankle left and rename the controller to ankle left controller. Right-click on the circle and go to Control Vertex, and we'll change the shape of the controller. Hide the joints and the IK handles so we can select the vertices on the circle. Grab the vertices and change the controller to a 3D shape. Select the center vertices and scale them down. Scale up the top and end vertices. Then, move them up along the y-axis. Move the center vertices down and increase the height of the shape. Turn on the polygon mesh and check if the controller is big enough. Duplicate the ankle left folder and snap it to the reverse right foot joint. Rename the folder to ankle right and rename the controller to ankle right controller. Double-check to make sure that all transformation values should store on the folder. The controllers should have a clean value. Before we apply constrain, let's think about the function we want. We want to use the foot controller to rotate and to lift the foot joint, so the Orient constraint does not fit here. Before we move forward, let's change the folder name to foot left and change the controller name to foot left controller. Now we have the same name convention on the joints and the controllers. Select the left foot controller, then select the reverse left foot joint. Go to Constrain, Parent Constrain. Check on Maintain Offset and check on both Translate and Rotate for the constrain axis. With the parent constraint, the controller drives the joint's position and rotation values. Select the right foot controller and add the reversed foot joint. Apply the parent constraint. Now, we have each foot controller fully functioning. However, when moving and rotating the foot controller, the ball controller and the toe controller does not follow. When rotating the toe controller, the ball controller does not follow as well. Now, we will be parenting the controllers so we can have followed up animations. We created reverse foot joints, so we will parenting the controllers in the opposite way. Hide the initial folder that is not in use. Since we want the ball to follow the toe movement, parent the left ball folder to the left toe controller. Keep in mind that we are parenting the folder to the circle shape. Parent the left toe folder to the left foot controller. Parent the right ball folder to the right toe controller and parent the right toe folder to the right foot controller. This is the hierarchy of the controllers. Now, if we rotate the toe, the ball should follow. If we rotate the foot controller, the whole foot will follow. We finished setting up rigs and controllers on the leg, and we will move on to the arm and hand control. For the arm, we will create the IK handle, the same as we've created on the leg. When creating the arm skeleton on your model, I recommend bending the elbow joint before rigging your model. If you leave the arm skeleton in a straight line, the IK handle doesn't know in which direction to bend the arm. In this case, we will have to set up a preferred bending angle for the elbow. The elbow joint already has values on it, however, I created a keyframe at 0 seconds. I hide that keyframe by setting the current project to start at frame 1. That means if I rotate the elbow joint at a later time and don't create another keyframe for the change, the elbow will set back to the initial position. Now, let's rotate the elbow joint in the direction that we want it to bend. Go to Skeleton, set Preferred Angle. Choose the hierarchy as the angle options. Now the program knows how to bend the elbow joint. Set preferred angle for both arms. Switch back to the initial pose by grabbing the time slider to a different time. Now, we can create IK handles on the arms. Go to Skeleton, create IK handle. Make sure to set the current solver to Rotate Plane Solver. With the Rotate Plane Solver, we can bend the elbow and can use a pull vector to aim the elbow to different directions. Click on the upper arm joint, then click on the wrist joint. Now, we have the IK handle for the left arm, and it bends the elbow in the direction we want. Create the IK handle for the right arm as well. Rename the arm IK handles. Duplicate the initial folder, and we will use it to create the pull vector for the arm. Turn off the polygon mesh. Rename the folder to elbow left. Hold the V key and snap the folder to the left elbow joint. Rotate the folder in 90 degrees along the x-axis. Move the folder back. And rename the controller to elbow left controller. If the controller is too big, you may scale it down. Remember to freeze transformations and delete history on the controller. Again, the controller should have clean value, and the folder can keep the transformation values. Duplicate the folder and snap the folder to the left elbow joint. Move the folder back. You can copy the translate Z value from the left elbow folder and paste it onto the new folder. Rename the folder to elbow right and rename the controller to elbow right controller. Select the left elbow controller, then add the left arm IK handle. Go to Constrain and apply pull vector. Now, we can use the elbow controller to aim the joint in different directions. The arm IK control and the pull vector control should allow us to create any pose with the arms. Select the right elbow controller and add the right arm IK handle. Go to Constrain and apply pull vector. Now, let's get the hand controllers to work. The arm IK handle should follow the hand controller in rotation and movement, so we can simply parenting them together. Select the left arm IK handle first, then add the left hand controller. Hit the P key to parenting them. Now, the hand controller works the same as the IK handle. Select the right arm IK handle first, then drop it under the right hand controller to parent them. You will have the same result as you hit the P key to parenting them. Now, we finished setting up the arm controls and we'll move on to the hand control next. We'll create the driven key on the hand controller and it will allow us to control all fingers with one slider. With the left-hand controller selected, go to Channel box, Edit, Add Attribute. Put an aim for the driven key, and it will show up underneath the scale channels. We will create a driven key for the fist pose. For data type, choose float. At the minimum value, type 0. That means when the fist-driven key set to 0, the hand will be displaying its initial pose. Type 1 at the maximum value. When the fist-driven key set is 1, the hand will turn to a fist pose. It will be added on the hand controller as a channel. And we could only set a value between 0 to 1. Set the fist channel to 0. Go to the Animation tab, Key, Set Driven Key. And go to the Tool Settings. In this window, we'll connect the hand controller to the finger joints and use the fist channel to drive the finger rotations. That means the hand controller will be the driver and all finger joints will be set to driven. With the hand controller selected, click on Load Driver. Then we will select the finger joints. Click on the thumb's third joint, then hold the Shift key and add the second joint and the first joint. Add the rest fingers' first 3 joints. By default, the driven window also has been set to the hand controller. But after we click on Load Driven, all selected finger joints will be loaded to driven window. Now, we can select the specific channels we would like to link. We will use the hand controller's fist channel to drive the finger joints rotate channel. Click on Fist in the driver window, then select all finger joints in the driven window and highlight their rotation channels. Now, the fist channel connected to the selected finger's rotation channels. Click on Key, and it tells the program that whenever the fist channel set to 0, the finger joints stay at current rotation value. Now, set the value of the fist channel to 1. And we will create a fist pose. Select the first 3 joints on the index, middle, ring, and pinky fingers. Rotate them to close the palm. Select the first 3 joints on the thumb and rotate them to place the thumb on top of the other fingers. Check if the polygon mesh was properly placed by hiding the joints. After you get a fist pose, double-check to make sure that the fist channel on the hand controller is set to 1. Go back to Set Driven Key window, click on Key. This will create the second keyframe and tell the program that whenever the fist channel set to 1, the finger joints stay in the current fist pose. Let's test our fist channel. 0 is for a relaxed hand, 1 is for the fist pose. We can type a value between 0 to 1, and it will generate the in-between pose for us. You can also add keyframes on the fist channel and create animation. By turning off the joints, I noticed a small issue on the hand. When we go to the in-between poses, all fingers close at the same time and they pass through each other. We can avoid this to happen by letting the thumb to bend after the other fingers. Set the fist channel back to 0. Select the first 3 joints on the thumb. Go to Windows, Animation Editors, Graph Editor. Here, you can see each joint's rotation value through a graphic. And by changing the graphic, you are changing the timing and the animation. Select the rotation channels. And then select the 2 keyframes that we created as the driven keys. Apply the Easy Ease to smooth the animation. Select the first keyframe. In Stats box, type 0.4 and hit the Enter key. It will offset the keyframe by 0.4. Now, when typing in 0.4 on the fist channel, the thumb stays still. After 0.4, the thumb starts to close, and the thumb never passes through the other fingers again. If you would like to create more gestures for animation, you can follow the same procedure and set driven keys. You can also set driven keys to control each finger. With the hand controller, we can control the arm movement and the hand gestures. However, we aren't able to rotate the hand. Select the hand controller and select the hand joint. Go to Constrain and apply the Orient constraint. Make sure the Maintain Offset is checked on. Now, we should have full control of the left arm and the left hand. Follow the same procedure to create a full control of the right arm and the right hand. For the eye control, we will build controllers that allow us to rotate both eyeballs at the same time and to move each eyeball separately. Each eyeball was rigged to one joint, and the eye joints are parented to the head joint. Duplicate the initial folder and rename it to Eye Left. Rename the controller to Eye Left Controller. Hide the polygon so we can focus on the skeleton. Snap the folder to the right eyeball joint and rotate it in 90 degrees along the x-axis. Select the controller and scale it down. We'll keep the folder's transformation values, but need to clean the controller's values. Apply freeze transformations and delete the history. Duplicate the folder, snap it to the right eyeball joint. Rename the folder to Eye Right and rename the controller to Eye Right Controller. Select both folders, move them to the front of the eyeball. Select the left eyeball controller, then select the left eyeball joint. Go to Constrain, Aim Constrain. Check on Maintain Offset and set Constrain Axes to all. Select the right eyeball controller and select the right eyeball joint. Apply Aim Constrain. Now, the eyeballs are aiming at the eye controller. The eyeball still follows the head joint's position, however, it aims the eye controllers. By move the eye controller, we can rotate the eyeball. Here, we also want a controller that can drive both eyeballs' rotation at the same time. Duplicate the initial folder. Rename the folder to Eye Group. And rename the controller to Eye Group Controller. We would like to place this eye group controller in the same position as the eye controllers. You can simply copy the transformation values from the right eye folder and paste the values onto the eye group folder. To place the folder in the center of the eye controllers, zero out the translate X value. Select the eye group controller. Go to Control Vertex. Select all vertices and shape the controller. Freeze transformations and delete history. Then, we can parent the eye controllers folders to the eye group controller. Keep in mind that we are parenting the folder to the circle. Now, by moving the eye group controller, we can move the eye controllers at the same time, and both eyeballs will follow. By selecting the eye controller, we can rotate each eyeball independently. Let's pack up the character for animation. The foot controller and the knee controller should keep independent and should not be parented to any other controllers. Same as the hand controller and the elbow controller. The hip controller will serve as the root controller of the torso. We applied Orient Constrain to the hip controller earlier, so it can only rotate the hip joint. We will change the constraint to Parent Constrain, so we can also move the hip joint with the controller. Now, we should be able to move the torso with the hip controller. The hands and the feet are locked at the initial position, and that's what we want. The hands and the feet should only be moved by their controllers. These are the folders for the controllers. We kept them separated so they don't affect each other. However, in some cases, we would need to move the whole character to a different position. That's to say, we would need to build a controller that allows us to move all controllers. Duplicate the initial folder, rename it to Character Controller Group. Rename the controller to Character Controller. Scale up the character controller so it can be easier to be seen and to be selected. Freeze transformations and delete the history. We will use this character controller to drive all other controllers. Select all controllers folders. Then, select the character controller, hit the P key to parenting them together. Now, by moving or rotating the character control, all other controllers should follow. By selecting each controller, we are still able to control each part of the character. Select the hip joint hierarchy and the two reverse foot joints hierarchy, hit the G key to group them. Rename the folder to Character Joints Group. Select all polygon meshes and group them. Rename the folder to Character Mesh Group. Delete the unused objects. When we move the character controller, the character meshes will follow. The dress mesh does not follow since it is not rigged. However, once we animated the character, we will attach the dress to the character as the end cloth, and the dress will inherit the animation. Now, we have a clean file hierarchy, and the character controllers are fully functioning. We can move on to animate the character now.